the rate of 0.005 moles per liter per second, per minute. What units did I have? In the exam I have second, but I think I had minutes. So if I had minutes, whatever is the unit I had in the example days, I think I may have mixed up the units in my notes. If I had minutes in my notes, minutes. If I had seconds, seconds. I had minutes? Whatever it was. Minutes or seconds. No unit converted to minutes, okay? So that's the second question. So let's address this problem. So we'll again go through the three steps, and now it will be good to do them all together without any interruption, so you see the whole thing together. So step one, as before, u prime is u minus u naught, which is 0. Again, in this case, is u naught minus u naught. Which means that u prime bar is 0. Andrea, question? Are we okay? Brian, okay? All right. D1 prime is D1 minus D1 naught. What is D1? What is D1? At time 0, it starts dropping from 0.200 at the rate of 0.005 unit concentration per time. So what expression, mathematical expression, can I write for that? It's the beginning value minus, okay, Mohammed says it's the beginning value, 0.200, minus the rate at which we're dropping, times time. Right? If I'm dropping at this rate, from the beginning value, that's the equation that describes what T is doing. Clear, everyone? Okay. Thank you. David?
Is that supposed to be used?
Which here?
No, the next one.
U naught minus U naught. Because U is U naught. Deviation is U minus U naught. U is U naught.
Are we going to do a case when that's not 0?
We're doing this. And D1 naught is what? 0.0200, right? So that means that the deviation is minus 0.005 t. So now I need to go to the dictionary. D1 prime bar equals. It's a constant times t. Do I have t in the dictionary? Do I have anything that would give me t in the dictionary? K equals 2. If I put k equals 2, what happens to this term? T to the 2 minus 1 to the first power over 2 minus 1 factorial, which is 1 factorial, which is also 1. So this whole thing becomes t. And what should I do with a? Yes.
What do you mean by u naught minus u naught equals 0?
No, u naught minus u naught is 0. U is u naught.
Oh, that's why.
Right, that's the previous example. All right, let's move on. So you can see that for t, to get t here, I have to use k2 and a0. So using k equals 2 and a equals 0, we get the coefficient minus 0.005. And what do I have for, if you use here, k2 and a0? 1 over s squared. So that's going to be times 1 over s squared. Okay? So minus 0.005 over s squared now. Okay, everyone?
You lost me after you put minus 0.200 after the equation.
This is the D1. D1 is the beginning value minus what it loses by dropping.
Yeah.
And the nominal value is D1 drop is 0.20.
Okay.
Right? If it's dropping at that rate, at time 0, this is 0.20. Okay? And it drops at that rate. So at any time, it's this expression. Minus the nominal value.
Okay.
Clear, everyone? So we found U prime bar, we found D1 prime bar. Step 2. Y prime bar equals GU of S times U prime bar, which is 0, plus GD1 of S, which is, okay, plus GD1 of S, times D1 prime bar, which is minus 0.005, now over S squared. So that gives me 0.011 over S plus 0.111 e to the minus 5S times minus 0.555, and listen, minus 0.005 over S squared, or writing it minus, I was thinking, 5.55 times 10 to the minus 5. And I have here 1 over S squared, S plus 0.111 e to the minus 5S. So that's my Y prime bar. Okay, everyone? All right, now. Using the dictionary, I can apply the second entry up there, step 3, to write again that Y prime of t is equal to 0 for t less than 5, h of t minus 5 for t greater or equal to 5. Well, now what is my h bar of s? It's different than before. My h bar of s is going to be everything excluding a to the minus 5 ohms. So where h bar is minus 5.55 times 10 to the minus 5 times 1 over s squared, s plus 0.11. Okay? As before, using the last entry, I have something e to the minus ds, something e to the minus 5s. The inverse of something e to the minus 5s is going to be 0 for time less than 5, the delay, and a delayed function h of t minus 5 for time greater, where h of t is the inverse of the guy of whatever multiplies a to the minus. That's h bar, and h of t is going to be the inverse of h bar. In other words, minus 5.55 times 10 to the minus 4 times 10 to the minus 5, sorry, times the inverse of 1 over s squared Rim, okay? Okay, very simple before. Now I need to find that inverse. It's not in the dictionary. It's an S, not a 5. So, positive fraction expansion for the inverse. So I have to positive fraction expansion. 1 over S squared, S plus 0.111, that's what positive fraction expansion. Adam.
C11 over S plus C12 over S squared.
See, I think the first one's pretty good.
1, 2, right.
Plus C21 over S goes to 1.
That's right. Root 1 is 0. And the multiplicity of that, Felix, is it clear the multiplicity is 2?
I guess, yes.
And root 2 is minus 0.111, and the multiplicity is 1. So, root 1 has S and S squared. Root 2 has just that. Which are the quick and easy coefficients? Robert?
C12 and C.
Sorry, yes. Thank you.
C12 and C21.
Absolutely.
-9.
So, let me quickly have someone calculate C12 who hasn't spoken before, hopefully. Tell me what do I hide. So let's do for now quick and easy. Tell me what, someone hasn't spoken.
Felix hasn't spoken.
I've been speaking the whole time.
You got it.
S squared.
I hide the S squared, and what value of S do I use? Thomas?
The 0 for
Yes.
S.
So what is the result for C12?
1 over point 100.
Right? You see that? So it's 1 over S plus 0.111. If I wait that S equals 0, in other words, 1 over 0.111, in other words, 9. Okay, C21, someone hasn't spoken at all. Rim. What do I hide?
S equal to 0. S plus 0.111.
I hide this.
So now I have 1 divided by S squared.
Yeah, and what do I hide? What value of S do I use now?
What value of S?
Yeah.
It's S plus
You write like you have
No,
no
but I need to do a specific value of S. I hide this, and I calculate some value of S. What value of S I calculate?
1 over S squared.
Okay, Megan said it, but let's see if remember, I calculate this at the value that makes the denominator 0. So what value makes the denominator 0?
S equals 0. Oh,
No.
S equals negative 0.111.
Exactly. So I hide this, and what value of S I use?
S equals negative 0.111.
Exactly. You get it? I hide this, and I use S equals minus 0.111. So this is C. So C21 is 1 over S squared, evaluate at S equals minus 0.111. In other words, 1 over minus 0.111 squared. In other words, 81. So that took it too quick away. Now we're ready for the second part. Only one coefficient left. Only C11 left is unknown. So, linear equation. Only C11 is unknown. Need only one S value. I need only one equation for one unknown. Tell me what would be a good S value to choose. Cannot be 0, cannot be minus 0.11. 0.5 would be good, but it's late. I want minimal algebra. What's an answer that would give me really nice algebra? For calculating C11. 1. So if we choose S equals 1, and we have left-hand side is 1 over 1 times 1 plus 0.111 equals C11 over 1 plus C12 we already found is 9 over 1 squared plus C21 is 81 over 1 plus 0.111. So do the algebra, and we have 1 over 1.11 minus 81, so I get minus 80 over 1.111 minus 9, and if you do that, I believe the result is minus 81. Is it? No, okay. Yeah, I think so. Yeah. Yeah. So the result is minus 81. So we found we're ready now to invert using the dictionary. So we found what this is. So h of t is, we have it, let's see, where did I put it last? Right. Did I erase what I needed? Where did I write h of t? Here. Up here, yeah. Up here. So h of t is minus 0.555 times the L inverse of this, which is the L inverse of the first term is, okay guys, I ran out of time, so I guess we'll have to finish it from this point. So we found this is, we'll continue it on Wednesday. Let me borrow pen and paper.